The ellipse again could be, I'll try and make the picture this way. And again, this is my x-axis. Let me use my x and y-axes. Or it could be up and down. Ooh. Try to stay the same color, but I screwed up already. Could look like that. And it depends what we have. This or that, the equation will change. Let's write a few things about it. If it looks like this, the equation for that will be x squared over a squared plus y squared over b squared equals to 1. What is a? A is this distance. A is always the longer side. B is this distance. The longer side here along which axis? Y, right? This is A. This is B. So if it stretch along the y-axis like this, that would be y squared over a squared plus x squared over b squared equals to 1. So A is always going to be the direction where the longer side. A is actually on the y-axis. That's why A is under y. A here on the x-axis. That's why it's sitting under x. So that's one way to remember that. Now, these points here that we use to create the ellipse, each one of these known as focus. And again, you'll have one here and one down here. Focus. I'm going to put a lot of junk on it. This point here is called the center. Again, that's right there, the center.
Vertex? No?
That's the vertex up there.
The origin.
Those. That's the origin here, the center, the origin. Yep. Now, these points were the end of the graph. These are your vertices. We call each one a vertex. And if it's up and down, there's your vertex. Now, a couple more things in terms of terminology. The longer side from the vertex to the vertex is called the major axis, and this is called the minor axis. I don't know where to write that in. So major axes, I'll just go like this. That's actually twice A. If this is A, that distance from here to there is called major axis. That distance from here to there is the major axis. The minor axis is actually 2B. That's the distance from this end to that end or this end to that end. Major, minor axes. This book actually has, try to put all the labels on it. They were kind of smart by doing more than one picture so you don't make the picture a mess there. So when they did it, they took two pictures. They said, this is the major axis right there, from this end to that end. This is the minor axis. This is the center. That's the vertex. That's the vertex. If it's up and down, again, the equation is y squared over a squared plus x squared over b squared equals to 1. So this is your major axis, that distance. And this distance up and down here is minor axis, the little distance. Now, let's take an equation, go through it, and see what we have. I want to graph this ellipse. Are we good? So let's say we give you this one. X squared over 25 plus y squared over 9 is equal to 1. I forgot to write one more equation, which I'll put it in a minute there. We need to graph it. Now, by looking at it, can you tell if this is along the x-axis or the y-axis? Why the x-axis? The bigger number, exactly. So the graph should look like, well, let's see what the graph is going to look like. Instead of should look like, let's pinpoint it. That means a squared is equal to what? 25. A equals plus or minus 5. 1, 2, 3, 4, 5. This is the vertex, which is what? 5, 0. That's one of them. There's another one here. 1, 2, 3, 4, 5. Right here. This is negative 5, 0. So A is 5. Positive and negative, bless you. Now, the value of it's 5. I'll leave it alone. Let's look at b squared. B squared is equal to what? 9. B equals plus or minus 3. 3 up and 3 down. Now my graph should look like this. That's what the graph there, ellipse, should look like. The only thing I forgot to mention is, how do we find where the focal points are? I have a feeling the focal points are right here. I have a feeling at 4, 0 and negative 4, 0 for this example. Why? Because to find the focal point, now we all know Pythagorean's theorem is what? C squared equals a squared plus b squared? Yeah. Well, not here. A is the bigger side here. A squared equals what? B squared plus c squared. Which means if you rewrite that, c is going to be what? The square root of a squared minus b squared. Plus or minus will be here. One will be on this end, one on that end. C equals plus or minus. What is A here? 5 squared, 25.
Formula
Yep.
that we use for the
Yep.
focal point?
Yep.
C? 9.
That's 9. Plus or minus the square root of 16, which is what? Plus or minus 4. So your focal point is going to be at negative 4, 0, 4, 0. While I'm having fun with it, what is the major axis? How long? 2a, which is 10. What's the minor axis? 2b, which is 6. So the major axis is 10. Minor axis is 6. You'll see me do an example in real life in a few minutes with it. Because I have something in my head stuck in a picture. I'll talk about it. Let me try another one. So that's this example. Let's look at that. Now, which one's the bigger one?
9.
The 9, right? So a squared equals 9. A equals plus or minus 3. X squared equals what? 4. X equals plus or minus 2. Notice the 9 under the y. That means it's going up and down. Let's go 3 up. 1, 2, 3. That's your vertex, which is what? 0, comma 3. The x value is 0, the y value is 3. 3 down. 0, comma negative 3.
So there is B, not X squared. B, not X squared.
K and X.
Oh, I wrote B. I'm sorry, I wrote x. Yeah, B. So the other numbers are what? Here's 1. Here's the 2. So the graph looks like this. Now again, where's the focal point? That's where C is, the focal point. It's plus or minus the square root of a squared minus b squared. 9 minus 4, 5, right? So a little more than 2, somewhere here. So this is one focal point, the value is 0, comma, I'll just go to the square root of 5. And there's 1 here, 0, comma, negative the square root of 5. Major axes, again, I'm finding everything we know about them. It's 2a, which is 6. Minor axes, 2b, which is what? 4. Again, the minor axis is the distance from this point to that point. The major axis is the distance from the vertex to the vertex. Now let's just put a little twist in them. Instead of just giving you the equations, just calculate that. Let me save these. Graph the ellipse. I'll say the given. I know it's an ellipse. And here's my ellipse. 49 x squared plus 4y squared equals 196. Notice I put a twist in it.
Joyous.
Let me pull my notes out. I said the standard form should look like this. Or this. That doesn't look anything like this.
Divided by 1.
You want that number to be 1, right? So how do you make it 1?
Divided by 1.
Absolutely. So it might look different. $49 into 196, how many times? 4 times, is it?
Yeah.
And 196 by 4, what's that number? 49? Now that looks like the format we know.
49 is in.
A squared is 49. A equals plus or minus 7. B squared equals 4. B equals what? Plus or minus 2. Which way it's going? Up, along the y-axis, because it's sitting on top of the 49. 1, 2, 3, 4, 5, 6, 7. That's a vertex. 0, comma 7. 1, 2, 3, 4, 5, 6, 7. 0, negative 7. 2, negative 2. So it's a skinny one. Looks something like this. I want to get the focal point. That means C equals plus or minus the square root of a squared minus b squared. 49 minus 4. The square root of what? 45. Here's the bad news. Your book probably going to make you calculate this, but give the exact answer. Yep. Which means don't use a calculator for that, and don't leave it like this because you can simplify it. 49 is 9 times 5, right? What's the square root of 9? 3, the square root of 5. So we know it's 45, so that's more than 6 and less than 7. Somewhere here. That's where the focal point is. The skinnier the graph, that means the focal point close to the edge. The fatter the one, it's closer to the center. So this focal point is going to be where? 0, comma, 3 the square root of 5. Just leave it like that. And this one here, 0, negative 3 the square root of 5.
That looks like a Subway sandwich.
Don't talk about food now.
That was so great. Yeah, it looks like one of the long ones.
Let's try another one. Might give you a different trick on it. Again, all these are ellipse. So this is what we know about this. Graph the ellipse. What's given to us? Given two things. One of them, it says the focus is 0, 8. And the second piece to that, major axis equals 34. Yep. I should, well, before even I get going on that, it says the focus where? Right here, 0, 8, right?
Yep.
Then there's one down here, 0, negative 8. So the graph has to look like this. It has to. If the focal point on the y-axis, the graph is up and down. If the focal point on the x-axis, the graph horizontally.
So if it was 8, 0.
Will be this way, correct. Yep. So that means y is going to be sitting, the equation for that is y squared over what? A squared plus x squared over b squared equals to 1. That's what the graph is going to be, just from knowing the focal point. If I know what A and B, I'll be in good shape. We know A, that's right. Major axes equals 2A, and that's equal to 34. A is 17. How do we find B?
Start doing some algebra.
No?
What about
C equal to
Yep, Million, what is it?
C equal to plus
He says C equals 8. Right there. See the focus. It's 8 units high. So you know that distance is 8 from here to there. That's your C, which equals the square root of what? A squared minus B squared. So square that, 64 equals A squared minus B squared. Do we know what A squared is? We'll find it.
8 is 17 squared.
So 17 squared. Yep, to get rid of the square root, you square both sides. In case you're wondering why we squared that, to cancel the square root. So bring that 289 to this side. 64 minus 289, negative 225 equals negative b squared. B squared equals what? 225.
B is 15.
Plus or minus. Doesn't matter, I only need b squared. So the equation that described actually this ellipse, it's y squared over a squared. A squared is 289 plus x squared over b squared, 225, equals to 1. This is 17 units high. That's A. This is 0, negative 17. This one is 15, 0. This is negative 15, 0. And that's everything about this one. We know this is 8, 0, 8. We know this 0, negative 8. That's a focal point, and that's another one. We know the major axis is 34. That was given to us. The minor axis is what? 30. So these two pieces gave us a lot of stuff. They told us which way the ellipse actually is turning, what is A, and what we can find also B from it. Again, sometimes they give you like the minor axes and the vertex. If they give you the vertex, you know what A is. If you give you the minor axis, you know what B. The minor axis twice B. So if they tell you what the minor axis is, then you know what B is. If they tell you what the vertex, you know what A is. So that's what they're going to do with these problems. Now an example for that, then I will call the ellipse a history. Pasco Road.
What?
Pasco Road in Springfield. You know what that is?
Oh, that's a road?
Yep. There is actually, what is that, the yard? You can buy home construction material from it. Bollard.
Oh, yeah, I don't shoot.
Yeah, Bollard. Right, you know where Eastfield Mall is, if you're not familiar with the area?
I know where.
There is the Golden Corral, right? If you're coming from the mall, you take a right. There's Golden Corral on the left. It used to be down there every week. It's been underpass. Every week, guaranteed, there's traffic jam. Why? Because whoever built the bridge at that time, it looked like this. Wasn't high enough. So the 18-wheelers will come in, boom, crush the top, and they're stuck there. And now you got to wait for the police to come in, back the traffic out, deflate the tires, put the 18-wheeler in reverse, get it back, put air on it, and get out of it. So
Which is time consuming.
they just fixed it. Every week almost, somebody will come in, don't read the sign, the clearance. They fix that. So I'm in charge of this project. I want to make sure we have something that looks like this. And let me give you some dimension. I don't know. I'll look here. I don't know much about what's the height of a tractor, but let's say the peak right in the middle is 18 feet.
Sounds about right. Should be.
Let's say the width of the road from here to there is actually 64 feet wide. Yep, no scale here. In my job, I want to put a sign here, but I'm saying, you know what? I want to block this section. I'm going to put a high curve so people can walk here, so that cars will never be able to travel on that one. So you got to stay within that distance. So if I give you that distance is 22 feet, what's the height of that bridge there? What is the minimum height that you need to have here? Because if it's anything let's say this number happens to be 9. They're going to put a sign that says height is 9 or less if you're coming close to that edge. If you're in the middle, you're okay. But if you go on that edge there, you're in trouble. So I need to know what that height will be. What that looks like, part of a circle, or an ellipse, not a circle, an ellipse there. So I got to look at that. Can we find the equation for that? We're assuming,
Is that the focal point of that? Or the
nope, that's just the distance. We're assuming this is part of an ellipse, like this. You're looking at 1/2 of that. So if you have 1/2 of that, first it's along the x-axis, right? So it's x squared over a squared plus y squared over b squared is equal to what? 1. Do we know what a is?
Yes,
What is it?
half of 60.
Half 64. That's what a is. A is 32. Do we know what b is?
18.
18. Let's see what these numbers are. What is 32 squared? 1024. What's 18 squared? 324 equals to 1. So that's the equation that describes that. Now, listen to this. We want to make sure that distance, the farthest you can go, is 22 feet in this direction, 22 feet in that direction. So it's symmetric, going to make it. So when you're driving through that tunnel, you got to stay between these two lines.
So A is 20.
So what's the height? Not A. Now we have a point here, right? We know the x value. We're looking for what? The y value. X equals what? 22. Can we find y?
Yeah, plug
Plug it in. 22 squared over 1024 plus y squared over 324 should equal to 1. What's 22 squared? 484 divided by 1024. This number is 0.473. I'm going to cheat, just use 473. I'm not using all the numbers there.
So y squared over 324.
Move that number there. Yep, y squared over 324 equals 1 minus that number, which is 0.527. Y squared, we're going to multiply by 324 to get rid of the fraction, is 170.86. Now obviously this is plus. The minus that means under the ground. We're looking at the plus side of it here. What is the square root of that number? The square root of 170.86? 13. We show it's a plus number. So the minimum or the maximum height here is 13 feet. It's 13.07. So if your track is 13 feet, you're barely going to make it if you just stay next to that edge there.
Most 18-wheelers are taller than 13 feet.
Then you better bring it closer, that road. If you bring it to say, oh, you know what, you don't need 22 feet to go through that. Let's make it 15 feet, and that will raise that piece up there. But the clearance on this sign should say maximum 13 feet. Now, if you go in the middle of the road, you're okay. But I'm going to cover for myself because I own that road. I don't want somebody to sue me. I want to say, hey, you're the dummy one. The sign says 13 feet minimum. I might even be on the safe side, say 12 and a half feet, just to cover myself. Now, if you let dummy to drive through it with 14 foot, that's your problem. I put that big sign right there, massive sign, neon, flickering.
Wow, saves you from
They can
liability.
miss it.
And if it's 13, by the way, I'm sure we have a safety, like in real life, we say 12 feet. Just in case. There's a snow buildup there, ice buildup under it, winter time. Just like when it says maximum weight for the elevator is 1,000 pound, that probably can hold about 2,000 pounds, 1,500 pounds easily. We always have that safety.
Some people don't know how they
But that's an example where you could use that, you know.